Now, before we get started on living on planets and living in space, there's something more broader that covers both of these topics, which are what humans need to survive. These consist of air, water, shelter, and food. There are two main methods of getting water. The first one being harvesting it. We can fly out to other asteroids and harvest it straight from the asteroids, or maybe there's already water on the planet that we're going to be living on in the future, like maybe at the north and south poles there's ice. On top of this, we can just fuse the elements oxygen and hydrogen to make water. One of the most efficient methods of farming in space and on other planets is called aquaponics. This is basically raising fish and plants in the same environment, and this creates a source of fish, which are basically protein, and plants, which can be a variety of nutrients. This is very space efficient and much better than traditional farming. Shelter is the factor where space and living on planets differ. Living on planets, there are many conditions that create a good shelter, like radiation, temperature, and gravity. But in space, it's mainly just the structure of the space station that you're living in. The air that you're breathing should be made up of at least 19% oxygen, and the rest should be nitrogen. But other gases may suffice, like hydrogen, argon, and krypton have chances of being good substitutes for nitrogen, but mainly 19% oxygen and the rest nitrogen. Another key aspect of living outside of the Earth is energy. This can be met by using solar or nuclear energy. Solar energy is basically using your star to generate power, and its efficiency can vary depending on many circumstances and many variables, like the distance from the star and maybe how much of the star the solar panels see every day. There are two types of nuclear energy: nuclear fission and fusion. Nuclear fission creates a lot of nuclear waste, and we should not turn to it as an energy source in space. But nuclear fusion holds potential to being the number one energy source in the future. But it is still being developed, so in upcoming decades, potentially we may be able to use nuclear fusion to power our missions in the future. Now we're moving on to living on other planets. There are many conditions that a planet needs for humans to live on, but the most important ones would be gravity, atmosphere, radiation, and temperature. The most optimal gravity for humans to live on is a gravity that's somewhat close to Earth's. If it's too low, if the gravity is below the gravity here on Earth, then our body and bone mass and muscle mass would shrink because we're working less. And if it's too much, then our bodies cannot survive as we are being pushed down too much, and it's too much for our bodies to bear. For the atmosphere, like I stated before, for air, it should be 19% oxygen and the rest should be nitrogen, helium, argon, or krypton. But most recommended is nitrogen. And the density at surface level should be 1.3 kilograms per meter cubed. Planets use magnetic fields to protect from radiation, and the strength of this magnetic field at surface level should be 0.22 to 0.67 Gauss. And to put that into perspective, one small horseshoe magnet is about 100 Gauss. Some other methods of protecting from radiation consist of having very thick walls in space outposts on other planets, but this is a very tedious task. So if we're ever going to live in space, it's more optimal to find a planet that has a magnetic field strong enough to protect us from radiation. For temperature, the human body temperature cannot get below 13.7 degrees Celsius or we just die. And anything above 35 degrees Celsius is harmful to humans. Now we will move on to living in space. The main aspects to consider when living in space are pressure, structure, heat, and air. For pressure, the cabin pressure should be 14.7 psi, and the walls should be made out of aluminum covered by a Kevlar sheet to protect from the harmful effects of space, and this makes the walls about 10 centimeters thick. The way the International Space Station generates heat is through a method called active thermal control system, which is basically it's always generating heat and pulling out heat to create a balance of heat within the cabin. And there are many layers of blankets to create insulation on top of the walls to prevent the heat from escaping. There are two parts of air, which are oxygen and nitrogen. To get oxygen, we can just harvest it straight from water by splitting the water into hydrogen and oxygen. And to get nitrogen, we can harvest nitrogen straight from crops, and nitrogen can be delivered to the space station. That concludes my part on living outside of the Earth. I will now open up this room so you may contribute to this conversation. Thank you for listening, and I will be active in this room a lot, so if you have any questions, you can ask me, and I will respond within a couple weeks.
Thank you, Max, for telling us how to live outside the Earth. Those are very interesting subjects, and it is fascinating. And I especially like the those photos. Those photos are amazing.
Max, you did a great job. I love it.
Hi, Max. I'm wondering why you're interested in this particular topic. What interests you about living outside of Earth?
I have a question, Max. I'm wondering if you had the opportunity to live outside of Earth, how far would you be comfortable going? Where would you go? What planet? What space station? And what would the decision look like for people if you only got one chance to move? Like if you don't like it, it's too far, you're not going to make it back, or will longevity carry us through a little longer of a trip at that point? I'm curious to know what you think about the human limitations and timeline in relation to living outside of the Earth.
Max, this is an amazing, amazing overview and very impressive given, I think, what, you're 12 years old? Incredible. Keep going. I have a question. I know the James Webb Telescope has spotted many, many more potential Kepler planets, and may even be able to detect gas emissions from those planets that would indicate the presence of life. Certain organic compounds are required to generate, for example, methane. So the presence of methane in the atmosphere signals that, hey, there may be life on that planet, or there probably is life on that planet. I'm wondering if any stats have come out, or if you've looked at how many Kepler planets might be reachable for us given our near future technology, and if there is some way to figure out which ones of those would have the right magnetic belt and atmospheric conditions for human survival. Maybe not flourishing, but at least for base human survival, because it seems to me that some of these things that we need to set up, like, for example, a magnetic field to not get irradiated, are much more difficult than others.
To be honest, my reason's really goofy and kind of mean. Like, when I was like 8 or something, I realized that like the problems here on Earth are very stupid. They're all based on greed and stuff. And space has a vast amount of possibilities and no arguments over stupid things. And that is why I wanted to like study more about space. This decision, like to live in space or not, really is really based on the human pioneers that are in us, like whether or not we want to go out into space and learn more and reach for the stars. And it's really like, should we stay down here and coop and like not be curious, or should we go out there and adventure and discover new things? So yes, I do want to discover new things, reach out, and go as far as possible to learn as much as possible. No, sorry, I have not, like, I've heard of the Kepler planets, but I didn't go in depth into them, but I did learn about, like, another potential solar system called TRAPPIST-1, which is basically a solar system with 3 potential planets, all within the habitable zone. There's TRAPPIST-1e, F, and G, and all of these have potential, but sorry, I do not know about Kepler planet.
I think you're ready now, Max. I just bought you the first volume of the Feynman Lectures on Physics. This will be a good one. You already studied a lot of physics. It's on mechanics, radiation, and heat. But yeah, I think this will enrich your understanding of the universe. Enjoy. It's coming tomorrow.
Thanks for buying me the book. I'll read it when it gets here, along with the 2 other books you bought me. And yeah, that's basically it. And to catch up on what I'm learning right now, I'm basically studying like rocket physics, like calculating gravity, Newton's laws of universal gravity, and like rocket propulsion and stuff like that. We are currently trying to live on Mars. Like, I'm reading a book called The Martian, and people are talking about living on Mars. Elon Musk's trying to get on Mars and stuff like that with SpaceX and stuff. But I feel that we should like look onto other options. Although Mars may be close, there are other options like Triton and Ganymede that have like potentials of supporting life. Ganymede, Triton series, all of these have water on their surfaces or ice and a global ocean underneath, and they contain the biogenic elements and any there's a lot of ways that the like friction forces and tidal forces can heat up the celestial objects. So I think we should be looking at Triton series and Ganymede rather than Mars.
Hey Max, I recently learned about an organization you might be interested in that's doing something really cool. It's called Grow Mars, and they have developed basically a dishwasher-sized greenhouse that grows algae, and in it there's a bioreactor that turns the algae into organic plastic. Like they take the hydrocarbons and make it into plastic that they then put into a 3D printing robot that uses the plastic produced to reproduce and replicate the greenhouse to make it bigger. So it's a self-replicating greenhouse that takes any carbon dioxide from an atmosphere like a colony or a spaceship from the people breathing in it. And it turns that carbon dioxide into hydrocarbons that are then used to make more greenhouses to process more carbon dioxide. Which is a really cool use of the CO2, and then you can use those greenhouses to grow food. So check it out. Also, if space is an area that you're really interested in, there is a DAO called Moon DAO that's basically composed of lots of scientists and engineers and astrophysicists who are working on designing a self-sustaining colony for the moon. I got in touch with them because I'm working on a self-sustaining city design for Earth, but I think that the two are really parallel. So I'd be happy to introduce you if you'd like an intro to some of the founders there.
Yeah, I've heard of something. Like, I'm reading a book called The Martian, and there's also a movie about it called The Martian. In the book, they talk about something called a CO2 reclaimer, where it takes the carbon dioxide in the atmosphere and removes the carbon from it. So like nuclear fission and stuff to split the carbon dioxide into just oxygen and carbon. And yeah, that's pretty cool. I don't know what a DAO is, but it sounds pretty cool. And yeah, it would be awesome if you would introduce me to them. Thank you for like offering it. And yeah, but like they're planning on building a colony on the moon. Like, is it like a organization or like a company or a corporation or something like that? Are they partnering with other companies like NASA or SpaceX?
The second link there is the link to the Discord server where all of the Moon DAO members talk with each other. A DAO is a decentralized autonomous organization, basically a group of people that all govern a system together and put resources into a community treasury.
AirChat is the only platform where 12-year-olds are explained what a DAO is.
Hey Max, I really like the topic of this room. I remember I had a phase when I was reading a lot about Elon's plan to occupy Mars, and your presentation actually gave me a lot of information that I didn't know before, so thanks for that. But I do have actually two questions. My first question is about creating an artificial air. You mentioned that that would require, in theory, 19% of oxygen, and the rest should be nitrogen. But there are other gases that can suffice, like hydrogen, argon, and krypton. Though I think on Earth, oxygen is about 21% in the atmosphere. But anyways, my point is about the substitution of nitrogen with the other gases, I'm a bit skeptical about it because if you assume that argon and krypton, for example, can substitute for nitrogen, you inherently assume that they can perform the same biological role as nitrogen. And I'm not sure there were any experiments where they tried to do this in the National Space Station or on the moon. Or maybe I'm wrong. I don't know if you found some trials for this. My second one is about the living conditions, which you described for pressure, heat, and air, which were accurate for an orbital station, as you mentioned. But I was thinking this would be different for habitats in other conditions, like other planets or moons. So, for example, the conditions on Mars would present different challenges and opportunities compared to living on an orbital station. Like take Mars, for instance, it's a lot colder than Earth. You can get down to minus 200 degrees, if I remember sometimes, at the poles in winter. So that's way colder than the coldest temperature ever recorded on Earth. So if we were living on Mars, we'd need to figure out how to stay warm in those extremely cold temperatures. So the technology needed would be different than the ones that we are now using for orbital stations. And if I remember, Elon's plan was about terraforming Mars to increase the temperature. So that would mean introducing greenhouse gases into the atmosphere, which would trap heat from the sun and raise the planet's temperature. But this is a theoretical case which take years, so it was more a long-term thing.
19% oxygen is the threshold, so anything below that is dangerous to humans. But for argon, helium, and krypton, all of these, they're not like perfect replacements, but they will suffice as you can survive in them theoretically, as they have like all the things that you need to survive. So just theoretically, if you think about it, do the math.
Hi Max, I just saw this on Twitter and I thought of you.
Sorry for the late response. I haven't been using AirChat that much lately. I've been working on some other stuff. But Mars, like for the planet's conditions, it's like a lot of planets there's a very big range. So I try to be as broad as possible and cover all the planets. So rather than just saying the temperatures that a specific planet needs to have, I said the temperatures that humans need to survive. So above 13.7 degrees as body temperature, and 35 degrees is fatal.
Okay.
And don't stop until I tell you to, okay?
Okay. 别打到自己了。
You get the entire height. I just wanted to share what I've been doing recently about space exploration. I've been working on a rocket that uses pressure, like pump pressure and water to like generate thrust. And right now, since I'm reading the Feynman's lectures on physics, I thought it would be fun to like actually use my physics because I want to be an experimental physicist, not a theoretical one. So I thought it would be fun to, like actually go out there and use and apply my physics. So yeah. And the data I've already conducted was that in that test, that rocket got up to 6.342 meters per second with a thrust of 0.89 newtons. It has a weight before fuel of 22.5 grams, and with fuel, you have to add on an extra 141.75 grams. The expulsion velocity is 6.342 meters per second, and the thrust to weight ratio is 0.558.